So what is a similar polygon? By definition, they have corresponding angles that are congruent, and then the corresponding sides are proportional. So corresponding angles are congruent, corresponding sides are proportional. Similar polygons, those are different than congruent polygons, because if they're congruent polygons, all the corresponding angles are congruent, all of the corresponding sides are congruent, so similarity is different. This is how you notate similarity. It's the congruent sign without the equal sign. So it's just a little mustache curlicue thing. All right, here we go. A ratio. What's a ratio? Hopefully you're reviewing back from your 6th grade math here. Comparing two numbers. So the comparison of two different things. We can write a ratio as a fraction. Write a ratio as a number, colon, whatever. We'll be using the fraction form though here because we are going to be setting these up as proportions. What's a proportion? They're two ratios that are equal to one another. So proportion would be two equal ratios. So 2 over 4 is equal to 4 over 8. How do we solve proportions?
Reduction.
Okay, you can reduce it down to 1/2 is equal to 1/2.
Or cross multiplication.
You cross multiply. So 2 times 8 must be equal to 4 times 4. So that's how we solve proportions. How would you solve this one? Well, cross multiply again. So 15 times x is equal to 9 times 5, which is 45. So x, how would you get x? Divide both sides by 15. X would be equal to 3. The lengths of the sides of similar figures are proportional. So we already talked about that. So if I have two triangles, and these triangles are similar to one another. So I have triangle ABC and triangle XYZ. So what would my similarity statement be? Triangle ABC, I'm saying, is similar to triangle XYZ. Now notice similarity means that they're the same exact shape. We didn't go over that, but similarity means that two objects are the same shape. Their angles, their corresponding angles are congruent. So this angle and this angle are corresponding, so they're congruent. But if they're similar triangles, then the lengths of their sides are proportional. So side AB, segment AB would be proportional to, oops, hold on just a second. Would be proportionate to what?
XY.
Okay, side XY. Sorry, I got screens popping up on me. Which means side AB would be over XY. Those sides are, those are corresponding sides. So AB over XY would be equal to or proportionate to side BC over YZ, which would also be proportionate to the left sides that are corresponding over XZ. All of these sides, we can set them up as proportions. Okay, what are my corresponding sides? That's going to be the biggest thing, is making sure that your corresponding sides line up. So here I've got two triangles right here. My corresponding sides, A over A and C over A prime, C prime. That would be 8 over 4. Okay, which would be 2. Let's check another set of sides. So notice whenever I'm doing corresponding, when I have similar triangles And I'm trying to compare them to see, okay, are they all proportionate? Are they all proportional? If they are, let's try them out. So side AB is proportionate to A prime B prime, which is 16 over 8, which reduces to 2. Okay, so far so good. All of our ratios are the same. And then side CB over C prime B prime is 12 over 6. So are these two triangles similar then? If they're going to be similar triangles, then all of their sides must be proportionate to one another. So I should be able to line up any of my sides and set them equal to any of my other sides that are proportionate. So AC should be equal to CB over C prime B prime. And is that the case? Well, AC over A prime C prime is 2. This answer right here is also 2. So yes, these two triangles, I could write a similarity statement and say triangle ABC is similar to triangle A prime, B prime, and C prime. So we're just working backwards. So if triangles are similar, then their angles are congruent, their corresponding angles are congruent, their corresponding sides are proportionate. If I know that my angles are congruent, if my sides are proportionate, then I know that I have similar triangles, which is what you're saying here. If corresponding angles are congruent, sides are proportional, then you've got similar triangles. So it just works vice versa there. The scale factor, that's just going to be the common ratio. The example we just did, the common ratio was 2, because that was all what all the ratios reduced down to. So it was 2. All right, here we go. Turn to page 538.
¿Qué página?
Exactly.
Trying to let Lauren in.
Welcome to the party, Lauren. What did you do? Go out for a burger?
All right, so number 1, let's solve these proportions. X over 100 is equal to 1 over 2. Cross multiply. Probably do this one in your head. X is equal to 50. Let's move down to number 7.
Question.
Yes.
How did you say did you say you cross multiplied or you? So wait, you did 100 divided by 2.
Cross multiply. If you have proportions here, cross multiply and set those products equal to one another. So x times
okay.
2x, 100 times 1 is 100.
I thought that you divided the 100 by the 2, right? Like I thought normally.
Oh no. Well,
That's what we ended up doing.
It is. Technically, you can look from side to side and say, okay, well, how did you go from 2 to 100? Well, you multiplied 2 times 50 to get 100. So therefore, in order to get equivalent fractions, I would have to multiply 1 times 50, because 1/2 times 50 over 50, I want this fraction to equal 1/2. And how do I do that? Well, I can only do it by multiplying by a value of 1. So that would be 50 over 100.
Yeah, I just wanted to make sure like the way I was doing it would work every time.
Either way works. Now, when you start getting to a proportion like 6.2 over x is equal to 5.89 over 12.6, now then you probably would want to cross multiply, because How do you go from 5.89 to make equivalent fractions? Not really sure.
Yeah.
When in doubt, cross multiply. All right, number 7. Now we want to find the ratio of the lengths in the right figure image to those in the left. So we've got a weird looking figure here. It looks something like this. And we've got all these side lengths, and we've got these ones right here. So find the ratio of the lengths in the right figure. So side 4 corresponds to side 1, which is equal to 4. Side 16 corresponds to side 4, which is 4. Side 8, side 2, which is 4, and 12, and 3. So what is the ratio? Oh, you know what? What did it say to find the ratio from what to what? It said find the ratio of the lengths in the right figure. So we have to start with this figure and then go there. So I go 1 to 4, that's 1/4. If I go 4 to 16, that's 1/4. 3 to 12, that's 1/4. And 2 to 8, that's 1/4. So what is my common ratio here? What's the ratio here of the smaller
1/4.
smaller quadrilateral to the larger one? It is 1.
1/4.
Wait, so why do we have to do the smaller one first?
The directions say find the ratio of the lengths in the right figure to those in the left figure. So we have to go from small to large.
Oh, okay.
So that's why we start with the sides of the smaller one first.
They're just making it difficult for no reason.
No, it's making me think. That's cool, but it's good. All right, given that the figures are similar, find the length of the side. So we've got 2 triangles that are similar to one another. So 3, 6, and 4. N, M, and 24. So there's 2 unknown values that we have to know. So we can set up proportions here. All right, well, I know that side 6 corresponds to side 24. Set proportions equal to, well, let's see, side 3. Remember, whatever triangle you start with, that needs to be in the numerator. Second triangle needs to be in the denominator. So make sure you keep corresponding sides as well as, okay, well, which triangle did I start with first? And so therefore n would be in the denominator. Cross multiply. 6n is equal to 72. So n is equal to 12. So now I know that n is 12. Now I got to find m. Set proportions again. Doesn't matter which set I use. I can use 6 over 24, or now I can use my new one, 3 over 12. It's equal to 4 over m. If I wanted to, I can reduce my fractions to begin with. I can reduce 3 over 12 to 1/4. 4 over m, and then cross multiply. M is 16. Or if I didn't think to reduce 3/12, then I could just cross multiply anyways. 3m is equal to 12 times 4, which is 48. M is equal to 16. You'll get the same answer there. For 10, 11, and 12, just make sure that your corresponding sides line up. Don't forget those. Let's do number 15. Are congruent triangles also similar? What do you think?
Yes.
Why?
Yes.
I believe that they will be.
Because Zach? I'm kidding. Because the angles are congruent. For congruent triangles, then the angles have to be congruent and the side lengths have to be congruent.
Okay, well, yes, for congruent triangles, you've got congruent angles and congruent sides. For similar triangles, you've got congruent angles, and what else do you have to know?
Corresponding sides
The corresponding sides are what?
are proportional.
Proportional. Ooh.
Okay.
I believe that they are due to the fact that there is already a similar sign in the congruent side. Ooh.
That wouldn't work on my test. So,
Makes sense though.
a good thought. I mean, y'all are correct, but you gotta tell me.
They did that so you could remember that they're similar.
Okay, you gotta prove it to me, not just give me a symbol. How can you prove to me that corresponding sides of congruent triangles are proportional to?
Because congruent triangles, that the sides would have the exact same amount, which the proportion would be 1 all the way around.
Excellent, Zach. That's more like it. Okay, if I've got two congruent triangles, that means all the sides are equal to one another. So now when I do corresponding sides are proportional, that's 3 over 1, 3 over 1, 3 over 1, 1. So yes, are congruent triangles also similar? Yes, they are. Okay, and then let's see here. I'll give you a hint for number 19. So you'll do this one on your homework. The corresponding sides
Huh?
hold on. Nope. I'll let you do that one by your own. Okay, so here's your assignment. You're gonna do,
Is it May 6th?
so we already did number 1, 7, and 9. So overall, you're gonna do numbers 1 through 16 all. And then I want you to do number 19. So we've already done a couple of those already. And that is it for your assignment, 1 through 16 all and number 19.
Awesome!
All right, kiddos. That's all I got for y'all today.
Call me.